Introduction, APIs and Web Scraping in Python. Have you ever wanted to get data from websites or apps automatically? APIs and web scraping make this possible in Python. In this lesson, we will learn the basics and explore simple, practical examples. By the end, you will know how to pull real data into your Python programs. Running the cell now. Let us practice together. As you follow along, try typing with me and pausing for questions. What is an API? API stands for Application Programming Interface. It lets different programs talk to each other safely and share data. Many sites, like weather or news, provide APIs for public use. Running the cell now. Here we are getting ready to talk to APIs by importing a Python library called requests. The requests library lets us easily send and receive data over the internet. We are now able to use code to reach out to websites and services. Running the cell now. Try typing the import requests yourself. If you get an error about requests missing, you may need to install it first. Remember to like this video if you are learning something new. We are asking GitHub for data through its public API. This line sends a message called a GET request to GitHub's API homepage. Printing the status code shows if our request worked. A code of 200 means success. Running the cell now. We are asking Python to show a small part of the response we got from GitHub. The response is a large text, but we are just looking at the beginning. Running the cell now. What does the output look like? Try changing the number to see more or less. APIs often return JSON. Most APIs send data in JSON format. JSON looks like Python dictionaries and stores data in pairs of labels and values. Luckily, requests can help us handle JSON easily. Running the cell now. We are using response.json to convert the response into a Python dictionary. The word type checks what kind of object we received. This confirms it is a dictionary. Now we can access specific parts of the data like normal Python code. Running the cell now. We are pulling out one piece of information from the API reply. This shows us the URL where user information for GitHub is found, using a key from the dictionary. Running the cell now. Try looking up other keys in the data dictionary. What is web scraping? What if there is no API available? We can collect data from websites by reading the HTML directly. This technique is called web scraping. Python makes this possible with the Beautiful Soup library. Running the cell now. We are getting ready to read website content with another library called Beautiful Soup. Beautiful Soup helps us search and extract information from the messy code of web pages. Running the cell now. We are telling Python which web page to load. Now we use requests to fetch the page's content, just like we did with APIs. We pass the page's text into Beautiful Soup, which acts like a guide for finding what we want in the page. HTML.parser is a type of translator that helps Beautiful Soup understand web pages. Running the cell now. We are asking Beautiful Soup to collect all of the quotes from this example web page. It searches for all span elements with the class called text. We then go through each quote and print it for review. This is a basic way to get useful results from a page. Running the cell now. Can you guess how you might collect author names too? Now we want both the quote and the author name. We collect the author names using almost the same process. Then we match each quote with its author using a loop and print them out together. Running the cell now. Notice how using lists and loops lets us organize our results. Web scraping can feel like talking to a website. Here we ask for your name, just for fun. It prints a friendly welcome message to show you how you can collect input from users. Running the cell now. Try entering different names and see how it responds. Sometimes when gathering lots of web data, it is polite to pause between requests. Import time pulls in a tool that lets us add a delay. Time.sleep means wait a moment. Here we pause for 2 seconds before continuing. This helps keep your scrapes friendly and reduces the chance of being blocked. Running the cell now. Handling errors the safe way. Not every web request will succeed. Servers can be down, or you could have typed the address wrong. We will now learn how to check if things are working and handle any problems. Running the cell now. We are trying to get a web page that probably does not exist. The try and accept keywords help us handle errors without crashing our program. If there is a problem, such as the site not being found, we gently print a helpful message. This way, your code is ready for surprises on the web. Running the cell now. Can you add error handling to other requests in your code? Try this mini project yourself. See if you can change the file name or format. If you are learning something cool, remember to subscribe and share this video. In this mini project, we are making a list of every quote and matching author from the page. All underscore quotes will collect them together for us. We then open a file to store our results, saving each pair on a new line. At the end, we get a message confirming our work is saved. A text file can be shared, edited, or used later by your Python code. Running the cell now. What other data could you try to collect and save? Explore changing the saved file name or adding extra information. Now let us ask a more specific question. We want to know how many quotes mention life. We check each quote's text, gathering those that use the word life, and count them at the end. Running the cell now. Try your own searches. What happens if you look for love or truth? This is a handy way to explore real data and see what words pop up often. This code finds the quote with the most characters using max and a helper function. Sorting or searching for the longest or shortest item is a common data task. We print the longest quote to see which one stands out on the page. Real projects use this to find records, reviews, or details that matter most. Running the cell now. Sometimes web pages change, or internet issues stop your scraping. We add a check to see if our list of quotes is empty. If nothing is found, print a friendly reminder to double-check the website or your connection. Otherwise, let us know how many quotes we did find. Running the cell now. Practice making Python handle errors and unexpected situations gracefully. Some websites ask who is visiting. They may block scripts that look suspicious. By sending headers, we tell the server we are a regular web browser. Headers is a small dictionary used to add details to our web request. This can help us access more sites without being blocked. Running the cell now. Are you ready for a challenge? This code looks for the tags connected to each quote. It pulls out all words used to label the quote, which might show what topics it is about. Try to understand or change this code to grab other details, and see how creative you can get. Running the cell now. What other page elements can you collect and print? See if you can make your own scraping script from scratch. Lesson recap. You learned how to use Python to request and process data from APIs. You discovered web scraping for data without an API. You used Beautiful Soup to find and print quotes and authors. You practiced saving, sorting, and handling errors with web data. Now you have real tools for diving into information from all over the internet. Running the cell now. Try experimenting with new websites or APIs. Practice will make you confident. Thank you. What is next? Keep exploring different APIs and websites. Comment below what data you want to scrape next. If you enjoyed this lesson, like, subscribe, and share with a friend. Happy coding! Running the cell now.